Hello everyone, welcome to our webinar today. This session is introducing Rhino and Lands Design as a complete pack for your landscape architecture projects. So those who are not familiar with Rhino, don't worry. We are going to have an interview of Rhino also. So let's start. What's Lands Design? Lands Design is a professional landscape software with BIM technology. It lets us to produce drawing in 2D, then model your project in 3D. It automatically generates the list of plants and other materials. And also there are several tools for animation and visualization of the project. There are two versions of Lands Design. One works on top of AutoCAD and Civil 3D, and another on Rhino environment. But with the same license, you may have both versions. Lands Design nowadays is used in landscape architecture, in green infrastructure by civil engineers, in urban planning projects, and in environmental projects for modeling the forests and this kind of projects. Let's see its main features. First of all, Lands Design includes an extensive plant database, which includes several filters that lets you to select the adequate plant based on climate, plant type, and many different parameters. Each plant species includes different displays for 2D and 3D. There is a realistic 3D model for each plant species, and as you see, there are botanical information, but you will see that more later on. There are different display modes. One is conceptual. You can shift between different display modes just by one click. This is the conceptual one, the detailed one, the realistic, and then you can shift between 2D and 3D just by one click. So just you can see the project in 2D and 3D. You can customize the plant species inside the plant database. In this way, you can create or modify an existing plant if you are not satisfied with that, or if you feel that the plant database miss any 3D model. For inserting vegetation, there are different modes. One is, of course, individually. Also, you can insert them by paint mode. You may be familiar with this mode in other programs, maybe. You can convert points to plants easily just by one click. Also, you can convert blocks, 2D blocks or 3D blocks, to a realistic model plant species in Lands Design. You can draw a row of plants, and the row may be combined with different plant species, or create a forest. We have shrubs which let us to indicate the density per square meter or per linear meter. And also we have ground covers that let us to have like the density, the unit per square meter, for example. For topiary, we have topiary tool now that let us to cover any 3D shape with natural plants in Lands Design. So once you have your 3D shape, you cover it with suitable plant species for topiary. And finally, this plant will be listed in plant list of Lands Design. You can change its density or scale of plant and any kind of modification in edit panel. We have powerful tools for terrain modeling. We can convert points, lines, or combination of points and lines to terrain. Once the 3D terrain is generated, you can modify it easily by control point. You can create cut and fills and do different types of earth moving operation. You can divide the terrain in different parts, assign different material to each part of the terrain, and obtain the volume and the area of each part. Also, you can import a terrain just by indicating the location of the project on the map. So in this example, we are going to select an area, particularly in Spain, since we are based in Spain. And as you see, by indicating the zone, you can import it easily. Lands Design uses a global elevation database for that elevation information. And the precision in this way is one sample each 30 meters. It's quite useful for medium to large scale projects, of course. Also, you can insert the 3D mesh, including the satellite image of the project. Recently, we have added another feature that let us, in addition to inserting the 3D terrain and well, the satellite image, you can also create or import 3D buildings. So in this example, we are going to import Central Park with all its surroundings. As you see here, you indicate the zone, and Lands Design will import all that selected area with all buildings included. We have dynamic documentation tools that let us to produce the list of plants, earth moving operation, irrigation, furniture, and add the image of plants to the project by a special command for that. And finally, produce different types of layouts and documentation. We have parametric hardscape tools that let us to have parametric walls and curbs, parametric paths, parametric fences, and there's a block library for furniture inside the program. But of course, you can import any other blocks that are compatible with Lands Design. There are irrigation tools that let us to design an irrigation system in 2D. And the volume of material, the pipes and sprinklers and emitters are going to be quantified in Lands Design automatically. For visualization, we have work mode, visual simulation, sun and shadow tool, render, different possibilities for render, and an image filter inside the program. The animation you see here, the project is modeled with Lands Design, and the animation is made with Enscape in this example. We have in Rhino Grasshopper components of Lands Design that let us to go one step more and do the design process in landscape architecture with parametric design and with algorithms. So this is a simple example of what we can do, but there are unlimited possibilities that you can discover later on. It's actually a big plus for Lands Design. As you see here, we are going to populate an area by plants, but all the process can be done automatically with Grasshopper. The height of plants is dependent to their distance to the axis of this path. By moving the path, everything changes automatically. It's quite a simple example, but I hope you get the point. Another feature is that now we have the possibility to open Lands Design project inside Revit. So for those of you who are working with Revit environments, this feature would be quite useful. And now, as you see here, you can modify vegetation in Rhino, and all modification is applied here, or you can modify the terrain in Rhino, and everything appear also in Revit environment. The design process with Lands Design is summarized here. As you see, you can, for example, import a terrain, or if you have topographic contours, you can elevate those contours, and based on these elevated contours, you can generate a 3D terrain. Or if you have point clouds, for example, you can create a terrain based on these point clouds or DEM files. Once created a terrain, you can modify it. Later, you can zonify the project in different zones. You get the area of each zone and assign a label, a different material to each zone of the project. In continue, you can insert plants individually in a row or in a group of plants. For example, a row of plants may be combined with different species, and you indicate the distance between plant species as well. Plants may have natural variation, so in this way you can decide to have a little bit difference between the height and the shape of plants in a group of plants to get a more natural appearance in your project. In continue, you add hardscape and different blocks to the project. Well, you can move it, you can modify it at any moment. And then at any moment, you can shift between 2D and 3D easily. If you do any kind of modification in 2D, you will see that also in 3D environment. So if you are more familiar with 2D environment, you can just do all your drawing in 2D and finally click and see that in 3D. In continue, you get the list of plants and other materials that is calculated by the program. Just by one click, you get them, and finally you render the project. Well, so the workflow that we recommend to our users starts with AutoCAD, Civil 3D, or Rhino. Well, you need one of these platforms in order to be able to work with lands design, basically. In continue, when you have a drawing in one of these platforms, a 2D drawing, you continue modeling and designing in lands design. And lands design contains BIM technology. It produces the lists automatically at the end of the day. So for visualization, you apply a render, which is compatible. Like a list of renders are here, Enscape, V-Ray, Twinmotion, or any other renders that are compatible, like Blender, for example. You apply virtual reality, so you can see the project with headsets and walk through the project, or print your project with a 3D printer. For documentation, you can export your documents to Excel, PDF, or print your drawings, of course. You may have collaboration with other BIM softwares or other modeling softwares like SketchUp, Revit, or 3D Max. So you can import or export models from these programs into lands design or vice versa. And you can also import geographic data like GIS files, DEM files, digital elevation models, or point clouds into lands design. And lands design can generate a 3D terrain based on this kind of information. These are some projects that are done with lands design. And in summary, lands design is available for Rhino, AutoCAD, and Civil 3D. It has 90-day free trial. The licenses are permanent. We have free technical support for all our users. There's an educational license for students and teachers if they are interested, and it's quite at a reduced price. And the development of this software has been based on our users' feedback. That's why we are now here, and we'll get happy if we can receive this introduction. Let's continue with feedback from our users, who is going to show us the program.
Nice introduction, Elham. So we will see just what Elham has described in this presentation, but live, okay, live on top of Rhino. For those that are not familiar with Rhino, I'm going to just make a very short introduction of it and showing you the main features. So basically, this is the main interface. We can see that we've got 4 viewports, okay, perspective, top, front, and right. This is something that you can switch from here, from this menu. You can switch from any viewport. Also, you can double click here to expand one specific viewport and double click to get the 4 viewports back. Okay, so we'll be always working on one active viewport, even if we see 4 of them. Okay, as I click on one of these viewports, you see that this title highlights, and this is where we are going to work. So I'm going to work on the perspective now. I will maximize it. Also, you can navigate through these viewports from these tabs. Okay. And also, we've got here an additional tab, which is the traditional page layout. If you are familiar with AutoCAD, you will know this. Basically, this is like a kind of paper configuration where we will prepare the layout setting to print our project or the documentation. Okay, so basically we've got a detail viewport, which is a frame that is kind of a viewport to the model space. Okay, so when we double click in it, we get access to it. We can work on it, and when we double click again, we get out of this edition and we are back to the paper space. All right, so this works exactly in the same way as in AutoCAD, if you are familiar with that. So back to the perspective viewport. You can see here many tools. Don't worry about that. They are very all well structured, and actually there are different ways to access to all tools in Rhino. So we've got the menu here to work with curves, for example, or with surfaces, some geometry, solids, meshes, and so on. Okay, and we've got the basic geometry and commands also here on this side toolbar. For example, we can find here all the commands related to drawing 2D lines, or the commands to drawing curves. Okay, so don't worry, you don't need to know them all. Actually, you learn by running these commands, because every command just will ask you for the next step you need to do in this command line. Okay, so this is also an important dialog to keep open, because here we will just need to follow instructions asked by Rhino to go on with any command. Okay, so again, we've got here basic polygons. All right, 2D geometry commands to work with this 2D geometry. So basically fillets, chamfers, symmetries, okay, offsets, and many possibilities. Of course, that it's impossible to know them all, but you just look for what you need to do, and for sure you will find the proper command in Rhino. Okay, so we've got here the primitives geometry, so we can draw solids with these commands. All right, we can do extrusions of planar surfaces or curves, and cylinders, donuts, and many other things. And here we have also the basic translation or transformation commands. For example, when we need to move one object, scale it, copy it, okay, apply symmetry. So these are the basic commands. Okay, rotate it. Also, we can take advantage of this widget, which is the gumball. Okay, to move objects in Rhino. Okay, so we can just use these arrows to rotate it, to move it in one direction or another. Okay, or if we tap here on this arrow, we will be able to move it a precise value, 3 meters up, or any of these directions. Okay. Also here we can enable the osnaps. So when we draw a line, we will be able to osnap on the endpoints, middle points, near, okay, vertexes, and so on of existing geometry. And this will be useful osnaps that will help the drawing and the modeling process in Rhino. Okay, and I don't want to extend so much about this, because all these commands are common to many other 3D software. Also, I would like to mention here the properties panel. This is an important panel, because everything that we select, even if it's nothing selected, we will see here the properties of the viewport in this case, or the object selected. Here we will see the layer, the display color, all the attributes of geometry. Actually, here we've got also a layer panel. So Rhino also works with layers. That means that we can group geometry in layers. We can use that to switch them off, okay, to display or hide the geometry, okay, and and also assign attributes, line types, colors, print widths, so all these attributes to layers, so the objects can take them by layer. Okay, so again, if you are familiar with AutoCAD, for example, this is very similar way to work. And we'll see also how land design also integrates with this layers structure, because you can place the objects, the land design elements, according to to specific layers according to the object type. Okay, so by default, all the vegetation elements will be created in that planting layer. So we can easily hide vegetation elements if we want. Okay, so so in addition to Rhino, we have seen, we have this set of tools, which are the land design tools. Okay, so we can see here a first group of commands for inserting vegetation elements. Okay, we can insert plants in a different ways, as we have seen in the presentation. Okay, from individually, from points, from blocks, we can insert them in a paint mode. We can arrange plants in rows, in forests, shrubs, ground covers, or we can wrap piece of geometry with this vegetation 3D elements with this topiary command. And we've got also some civil work tools to create walls, fences, stairs, paths, or rows of elements that we can browse from the land design library. We will see a library of 3D objects, okay, that we can use. Here we've got all the terrain modeling tools, so we'll get to that in a few moments. If we switch tab, we can find all the documentation commands. For example, to insert sprinklers that can be distributed in an array mode, the pipe command, the commands to list the objects that we've got in the model. Okay, these are all the elements that we can list. And keep in mind that all these lists will keep linked with the 3D model. Okay, so any change of the 3D model will affect that list which will update. And we've got also commands to tag objects. Then we've got other tools to insert pictures, okay, labels, dimensions, slopes, areas, or blind shadows. Finally, we've got here another tab where we find a mixture of commands. For example, the edit panel, which I have already opened here, but when you run this, this panel opens, so we can just keep it as a floating, panel, or just dock it next to the others. And here is where we will be able to edit everything that we select. Okay. For example, if we select a plant, we will see the species, we'll see the age, we'll be able to modify that from here. We will be able to switch from one species to another. Okay. So we'll be able to edit the objects that we have selected. If nothing is selected, then we see on the right top area of this panel the list of the species that we are using. Okay, so we can just use this list to select plants by species. Okay, we can also double click here to hide them eventually. All right, and also the list of blocks. So when something is selected, from the right side of the dialog, we will see the actions that we can apply on this object. Okay, and on the lower part, we'll see the properties of this species, for example, or what we have selected. In this case, we have selected some species, and here we can change, for example, the different representation or display modes that we've got for this species. Okay, so we have seen that we've got two different 2D representation, and then we got elevations, conceptual shape, detailed, and realistic representation. When nothing is selected here, we can switch from these different display modes just by clicking on these buttons. Okay. So now we are using the elevations display, but we can switch to conceptual, detailed, and realistic. So basically, each species stores these different blocks as a kind of level of detail to show the plants in one way or another. The realistic is the one that is supposed to be more accurate, more detailed. Okay, the one that integrates all the materials and textures on the geometry, but still this is not the most fine representation. When we shut a render of this view, when we are using the realistic display mode, these plants will be replaced by an even more detailed plants, okay, in order that the render result is perfect. So, of course, this realistic display mode is the one that has the geometry is more complex. For that reason, there is an option to switch to a billboard representation. So the plant will be just surfaces that orients towards the camera, the viewport. So this is a good option if you have a wall with thousands of units and you want to still work in this realistic display mode, okay, and have a good experience, okay. I haven't explained that before, but Rhino provides different display modes, okay, to work with different ways of representation. Okay, this wireframe where we see the edges of the geometry, but we don't see the surfaces. We have the shaded where we see the surfaces, and then of course rendered. We have this ghosted mode. So we have different display modes in order that it meets our requirements for visualization purposes or for working modeling purposes. Okay, let's start modeling here. Well, in addition to this 3D display representation, we can always switch from the 3D representation of plants to the 2D representation with this button. Okay, so basically, when we click on this button, all the land elements will switch to a 2D representation. So here it would make more sense to work from the top viewport, and well, keep on working as a 2D drawing, but keeping in mind that all the elements will turn into 3D geometry when we switch with this button. Okay, and also here we can we can switch to this setting out symbol or to the ground drawing.
Well, before moving on to, I'd like to add just a quick note. Whatever you see about lands design in Rhino is available also in AutoCAD. The unique thing is that, well, there are some differences because the platform is different, but the commands that we are following during this session are the same in Rhino and in AutoCAD. So if you follow this webinar for Rhino, you will be available to work also with AutoCAD version. Well, thank you.
Yeah. So, okay, let's go to the perspective view. And let's start continuing the development of this garden. It's already started. So basically the idea is that we may start from a 2D drawing design, okay, where you just have the 2D lines maybe developed in Rhino or maybe from a DWG file. It really doesn't matter. And some of the first steps may be to get an idea of the areas in the project. Okay, we've got already a few areas here inserted. Okay, like this green belt or these bushes or circulation area. Let's insert a new area for this square here. So we'll move to the landscape documentation and run this zonify command. So again, we need to just follow the steps in the command line. So we can either pick an inner point inside a closed area or select boundary if we already have the polyline or the boundary curve created. So I'm gonna just pick inside here, and the zoning dialog appears. So I'm gonna call this playground, and zones are represented with a hatch pattern in 2D and with a material in 3D representation. So we can select any other hatch pattern, okay, like maybe some squares. And for the material, we can browse also into the library of materials that Lands Design provides and select another one. Okay, so maybe I'm gonna pick some grass here. All right. You don't need to take these decisions now, because later we will see how we can edit these features later on. So finally, you need to insert the label in one specific point. But now, if we select this area, we'll have the chance, to change all the parameters from the lands edit panel. We can change the title. We can change the hatch pattern. Okay. We can change the material. So we get the same parameters as in the insert dialog.
Well, there's a question. Does the polyline for zonify have to be a closed planar line, or can you use a dimensional surface?
No, it has to be a closed. I mean, when you select the boundaries option, it only accepts closed curves, okay, and also planar curves, because you can have like a closed curve, but it's not planar. It's it's elevated in the 3D elevation, so it has to be a closed planar curve. Okay, if you have like a network of curves and you just need a point in between, so then you can just choose the inner point option. Okay, so I'm gonna switch to 3D now, and I'm gonna start by inserting a plant here, and later on we will see all the terrain possibilities for this upper area. So when we run the plant command, we get this dialog. In this case, we've got already few plants inserted, so this dialog also shows the species that I'm already using here. But in an empty document, you will have this totally blank. Okay, so in this case, you need to browse in the plant database to search for the desired species. And here we've got all the parameters and characteristics to look for the desired plant. So if you explore that, you will see many possibilities that, as long as we select these options, the list will filter those plants that match with this criteria. Okay, clear this. And you can also use the search box. And also here there are a few groups of plants. For example, there are over 8,000 species in the plant database, but not all have their own specific realistic representation. That means that in some cases, some species use the most similar, realistic representation according to the shape or the plant type. So, for example, there is a group of plants that come with a render. So in this group, we will filter the plants that already have a specific realistic representation. Okay. All right. So let's look for example, a lemon tree. So I'm gonna just look them all. I'm gonna look it for as a citrus lemon.
Well, you can look for the name of plants by typing a part of its name or its common name, or you can search for by filters by categories. As you see, when you apply some filters, you will see that some other filters disappear. Right now you see that attractive bark and suitable for a screen is disappeared about when we are looking for citrus, because now we are selecting plants that are a type of citrus, and there is no citrus that has an attractive bark in this case.
Let's check the properties of some of these species. For example, here we can open the technical sheet for the lemon tree. We can navigate through these tabs to change all the parameters for attached to this species. We can click on this button to change any detail. For example, we can change the tulip crown assigned to that species. Okay, so we have here all the blocks that come along with library, and we can change the one assigned for that species. If you have any tulip block, you can also choose it for the 2D representation of your plants. Okay. And if we explore here the renders tab, we can open the plant editor, which is this plugin that develops the 3D blocks for the realistic representation of plants. We can play here with all these parameters, okay, to find the most appropriate representation for species. Okay, and here we can also assign a texture for the trunk, a texture for the foliage, fruits. Okay, and we can save this definition as a new definition assigned to a specific season of the year. Okay, so later on, a single plan can achieve different representations, and depending on whether we will render the scene in one scene or another, the plan will be represented in one way or another. I'm gonna take out the changes now. I'm gonna say that I'm not gonna change anything right now. I just wanted to show you how to change that. I should apply the changes and I'll just cancel this. Yeah. All right, so we have our species selected, and I'm going to just insert it. We can define the size of this plant here in this insert dialog. And finally, insert it here. Okay. And now again, we can select it and modify the parameters as we have seen before. So before we move on with the other ways to insert species, let's check the terrain features. Okay. We can see already we have a surface in this model. This is basically a Rhino surface we have modeled with these commands. Okay, just by adding control points and modifying these control points to that surface, we can get the desired, topography. So it's kind of a free-form modeling when we work with Rhino Nerves geometry. Okay, and there is the option to select this surface or any other Rhino object, and here from the lands panel, tag it as a terrain. When we do so, this will be considered somehow like a land terrain, even though all these operations won't be available on this object. But we will make it possible that when we copy or when we insert elements over this surface, the plants will detect this surface as if it was a terrain and will project it automatically on top of it. Okay, so it's a very handy option to project vegetation elements on a specific surface. But of course, this is not going to store all the parametric features, all the smart features of a true land terrain object. So let's create it. There are different ways to create terrains. We have seen how we can import them from the web. In addition, we can create them from the digital elevation modeling files. Okay, but also in a typical scenario, we will get a DWG with all the contours of the topography, and in some cases even in a flat position. So we will need to elevate first these curves in order to later on create a terrain. So there is a command specific for that purpose, the elevate curves. So this command will show this dialog that asks me to draw a line, and all the curves that intersect with the line will be elevated according to an increment, okay, an interval. So imagine we put here a value of 2 meters, we click apply, and we can see here how the curves elevate. Maybe 2 meters too much, so I'm gonna set it back to 1, say apply, and that's it. Also, we can specify the start dimension elevation. I close this. So now I've got the curves already in the desired position, and I can run the terrain command. Just notice here that we've got this option checked. It's an option to create a terrain based on a gridded surface that lets us control the size of the cell. Okay, so the smaller this cell size, the more accurate with the input data it will be. But if we check this, we'll get a pure duality triangulation mesh based on the input curves. But I recommend using this option. Okay, so we'll have the full control of the accuracy of this terrain. So we just need to select the curves. We're going to use it for this terrain, and it is created. I can see there is a gap here. So imagine that you forgot to include some contour curve. So if I click here, I can see I've got another curve. So let's imagine that we want to integrate this curve also for the terrain calculation. So you can do this with the add contour command. So you select the terrain, you pick that curve, okay, and this will be integrated into the terrain that will be adjusted to fit with this new curve. Another thing that we can do here is to define the boundary. So I think I've got here a boundary curve. I'm going to show it in Gospel to display the curve. Okay. And I would like to trim the terrain so it fits exactly with this perimeter. So there is another command to do so. The pick boundary command. And again, I just need to follow the steps in the command line. So you're going to select the terrain. I pick the closed curve. And the terrain will shrink, okay, in order to fit with this new perimeter. Okay, I'm gonna put this back to rendered view. Actually, I had these curves in a specific layer, so I'm just gonna, I think it's this one. Yeah, I'm gonna hide it because we don't need these curves anymore. Now, if we select the terrain and we activate the control points, we will see that it has inherited the control point, the same control points as the curves used to generate it. That way we can pick any of these control points, okay? And with a gumball or just by moving them, we can change the topography of the terrain. Right? We would want to select, you know, all the control points of a curve, or just basically the curve. We can use this this arrow to move all the curve in another position. Okay, so now if we switch to the 2D representation, we will see the terrain control curves instead. Okay. And there is a nice way here to show them both. So show 2D and 3D, which for terrains will be a good option, okay, to give us good feedback about the topography. Actually, if we select the terrain, here under parameters area, we can redefine all these values. We can make a smaller cell size. We can edit the contour lines. For example, instead of a number of contours, we can set the distance between contours, which makes more sense, of course, always. And also we can enable this index contour. So we get a slightly different attribute every certain number of contours. We can change maybe the size of this text. Okay, so you can control everything from here. And well, let's apply some operation. This is somehow the original terrain, and from now on, when we apply cuts and fills, paths, holes, all this data will be stored into the terrain, so we'll be able to calculate the amount of volume that has been added or subtracted from the terrain. For example, let's insert a path. So to do so, we need a path curve. We already have it. It's important to have this path curve already positioned in the 3D model space because the terrain will try to adapt to fit it with the position of this curve. Okay. So if we have the curve in that position, in that elevation, all the terrain will grow according to to meet this curve. So I'm gonna do this right now. And now I can run the path command. Okay, so within the terrain options, I got this command. And again, for all the steps in the command line, I select the terrain. I define the width of the path, let's say 3 meters. I define an angle for the slope, basically how the terrain will be modified according to meet, the axis of this path according to a specific angle. And finally, select the curve. And we can see here the well, the path on the curve. Now, if we select the terrain, we also can change the control points of this path, which are different than the original curve, which somehow is not linked anymore with the terrain. And if we select the terrain, we go to input data, and we can find here the path operation and change the cut and fill angle, the width, and any other detail.
There's a question here.
Yes.
About the difference between two types of paths in lands design.
Okay, yeah, there is a specific command for creating paths, which is different than this path on the terrain. So this one just changes the terrain topography according to, as we have seen here, according to fit it with a path curve, while this other command just makes an extrusion of a profile along a curve. So this is something, for example, imagine that we've got a profile like that, and we've got a path following that curve. Okay, so with this command, we could select a section profile. Actually, this one is pretty much the same thing, so we can have control of it parametrically, and then we select a path curve, and we'll create a path object like that. Okay. While this other command just changes the topography of the terrain. So in this case, we select the path, and we can change the alignment. Okay, and we can also change the profile. So we can shrink it and change the profile. Okay, to modify its profile. Also, this command is used to create this kind of curves. Okay, if you have already a curve, imagine that we want like a 20 by 20, a curve here around this playground area. So we could use the path command. We'll say here that this is 20 by 20, and instead of selecting an open curve, we could use this closed curve to create this curve.
Well, basically, you can use also the wall tool for that issue.
Yeah. With the difference that the path can get any profile, while the wall command just has a rectangular profile. Okay, so we have done some operations on the terrain. Let's list them. So here in the documentation, we've got here the listing tools, and we can insert the terrain list. And of course, we added created an operation, and that means that the terrain has been modified according to the original one, so we can measure the amount of poly, amount of fields, and the widths that we have applied on this terrain.
Before moving on, can you please create a cut and fill a flat area, for example?
Yeah, sure. Okay, let's imagine that we want to flatten an area around this side of the park. So I'm just draw a rectangle here. Okay, this will be area I want to flatten. It's important that this position of this rectangle is in the right elevation, because this will determine how the terrain will adapt. So we have part of the terrain inside, part of this area inside the terrain, and parts outside. So I'm running the cut and fill command, select the terrain, select the angle, and again select a path curve, and this terrain will be flattened in that area. And just notice here that the terrain list has been updated with this information. Okay. Also keep in mind that when we add the divisions on terrains, like we create paths or custom fields, also a division of these areas is created. That means that we can change the material on that area. Now, if we select that terrain, and we go to, sorry, to escape, select it again. We go to the input data, and we select the divisions from here. We'll be able to assign a material. So we can browse and select different kind of grass for this area. Or for this cut and fill, with subdivision number 2, we can also use a different texture and maybe select some gravel. Okay, so that's the option to the way to assign materials on these divisions. Okay, let's go on inserting a few more vegetation elements here. For example, we could create a forest on that side of the project. I'm going to work from the top viewport now, and I'm going to disable this because I will insert the forest. I will select any of the existing species, for example, insert plantanoides. And just notice here this checkbox, the natural variation, that will make that all the plants of this forest not be exactly the same height. So according to this percentage, the plants will have slightly variation in terms of size. So they will look a little bit different from one to another. Also, when we enable the random rotation, all the plants will be rotated slightly from one to another. So everyone will look like an individual item. Okay. And under this forest tab, we set the parameters of the forest. So we can say we want 30 units with a minimum distance of 2 meters. And now we can either select an existing curve or draw it, selecting any of these options. I'm gonna draw it through a polyline. Okay, so I can define the polyline like this. I don't really need to close it. I mean, I can do right click to end the command, and the boundary will close automatically. And let's take a look at this forest in 3D. Of course, this is a random distribution of the forest. Here, if we select the forest, we can, play this distribution pattern as many times as you wish. But if we want to create like an ordered array, we can choose here the array option and say, okay, I want a 4x4 distribution of plants. Also, it is possible to combine species in a forest. Okay, so we can add here new elements, and then just by selecting one or another, we'll be able to edit the specific selection and assign a different species from that selection. Okay, so we'll have full control of how these elements are distributed and combine different species in a forest. All right, different ways to insert elements. Also, we have here rows. Okay, a row also can combine different elements, as it happens with forests. But let's take a look at the ground cover, because unlike individual plants, this uses different representation type. Okay. So if we browse in the plant database for species that are used in ground covers, we can find already those that have a specific representation for that. Okay, I can select this this one, and also ground covers have a 2D representation in 2D. Sorry, a height representation in 2D. And now I can also select the boundary or draw a rectangle. Maybe I'm gonna draw something here. Doesn't necessarily to match with this area, but we can see here that the ground cover just goes over the terrain, okay, and adapts to it. I haven't mentioned that before, but this happens as long as we have this pattern enabled. Okay. If we forgot to enable this, and maybe we insert maybe a new plant, you will notice that the plant will be created in the where the construction place, okay, in the default elevation. But later on, we can select it to adjust to terrain, okay, to adjust it to the terrain. In any case, I recommend leaving this, pattern enabled by default. Okay, let's actually even the forest as the ground cover commands are used for vertical gardens. Okay, so when you have, for example, a vertical curve, you can use the forest or the ground cover to create this distribution on that curve. So if the curve is vertical, we'll be able to create that on that surface. So, for example, I'm going to run the forest command, and actually there are certain species that have a specific representation for vertical gardens, and they are grouped here, okay, with a specific name. All right, so I'm going to select any of these species, and I'm going to select the one that is used for the vertical garden, and I just need to define the minimum distance will be maybe this, and select this curve to well, maybe I will add here more units. Maybe I need to decrease, this minimum distance in order to handle all the amount of units that I've specified here.
Well, you can combine it with other species as well, no?
Yeah, sure. Okay, let's take a look at some of the other civil work tools. We have seen the path command. We have mentioned the wall, but let's see how it works. So it's basically a parametric object with a thickness and height. Also justification, we can select the left and start drawing, a wall from these options, a polyline. So I'm going to enable the oscillate, right? I'm going to oscillate on these points to draw the wall. Actually, here I think the wall snaps onto the terrain because I have this. Well, you see, since we had this icon enabled, also the fences, the walls adjust to the terrain. So in this case, I can later on select it and just undo this operation saying don't adjust to the terrain. So we'll go back to the zero elevation. Walls have a material by default, okay, have a thickness and a height. But if we want to make a wall equal to another one, we have here an interesting option called copy properties from another object. So we will automatically make it equal to an existing object. Okay. All right. So we can insert now some row of elements. So I'm gonna select this command. I'm gonna browse in the block library for an object that we can distribute along a curve. So maybe for lighting, but you can explore here different blocks that are available. Okay, there are stones, people, water games. Okay, line fountains, and I'm gonna just pick one of these elements and create here a row of lights. There are several options to orient this object along a line. Okay, let's do perpendicular to the axis. And here in the row, we'll define separation or the total number of units. I'm going to select this axis, which is in the middle of the path. I'm going to define it an offset. Okay, and that's it. I select the curve, and I got these street lights next to it. If the orientation is not the desired one, okay, you can select these objects, and here, well, just play with the options to switch their position. Yes, there's a question.
The question is it possible to use PBR or SBAR materials?
Yeah, I mean, you can assign any material that is available in Rhino, not only those from the Rhino library, but those from maybe Flamingo or V-Ray, Maxwell, any render engine that works on top of Rhino can be used with land design elements. Okay, so for terrains, for walls, we have the option to select any material loaded into this document. Okay, in addition to materials that are provided by land design. Okay, let's take a look at the documentation tools. We have seen how to create areas. We have listed terrains here, terrain operations. We can list also plants. So basically here, we define an insert point for this list. And again, these are a live list that will update when we apply any changes on the 3D model. If we select this forest and we change, this array of 5 by 5, you can see how these values update. If we select the list, we will be able to see all the fields that appear here. So we can add the initials, so we can add the density that will be actually useful for ground cover. Okay. And we can also add like custom parameters here. And this is something that needs to be done in different steps. So we need to first create a parameter from the document properties, something that we can access from the Rhino actions. So we can, under this parameter section, we can add a parameter called price. Sorry. Say category general. Okay. Okay. And now, when we select any item, like these 3 elements, we go to the properties panel, and under this I of information, we can see that this is called parameters, and we can add here a specific value. And now, if we want to see this value in the list, we select the list, and under the fields to show, we will see this new parameter that we have created. If we enable it, of course, we will see only the values that we have added to specific plans. Okay. So you can add custom fields to the list and add values to the geometry to be listed there. Actually, this list can be exported to Excel. All right. And well, we can print that. We can export as HTML file or Excel. And maybe we can also insert here. Actually, I'm gonna work into it now. And I'm gonna insert here a zone list. In this case, I'm gonna enable the symbol icon. Okay. And I'm gonna insert also a urban block list with all the items of street lights. Okay. We can enable the plant shadows. When we work into this is a good option to have a better representation of of the plants in the 2D model. These plant shadows are basically a hatch that have these these parameters, the direction of the sun or the head, and they are not necessarily linked with the sun. Okay, because Rhino provides an option of enable the sun, especially when using rendered mode and the lighting is using these rendering settings. We can simulate, the kind of sun or shadow analysis along a day or along a year. These 2D shadows, they don't really link with this simulation, but this is used to have kind of 2D feedback of the plants and 2D representation of the model. Actually, what I was mentioning is that when we're working in 3D, maybe I'm going to show this in 3D. There is a panel here called Sun. So we activate the sun, and then we can well, specify where we are, in the world. So we're basically in Spain. I want to pick area near Barcelona, and well, just like playing with this slider to control the different time a day or different moment of the year, we can get a rough idea of how the shadows will apply on this project. Okay, this is not very accurate, but can give you a good idea of how the shadows will be. Okay, in addition to get a nice view of the project. Okay, I'm gonna switch to 2D. I'm just gonna show a few more details about 2D documentation. For example, we can add dimensions to plans, and we can add slopes. For example, these dimensions is interesting because you set a region coordinates, and then you define linear or ordinates. And when we pick a plan, this will show some coordinates according to this original point. And if we move the plan to another position, these coordinates, these dimensions will update. Maybe it's worth it to mention also the slope. And we want to measure a specific slope from one point to another. So we'll draw a polyline, and we can see, the slope from two different points. We can also measure the slope from curves. So we can run this command, and instead of drawing a curve, we can select that curve, which is the same as the, we use it for the terrain, and get the approximate value for the slope of this path. Okay, so let's see some of the animation tools before finishing. So I'm going to work now in the 3D representation, and I'm going to open the launch animation panel from here. So this is an additional panel that will let us place some animations on the model. So first of all, I need to select a path, a camera path. I'm gonna turn on layer when I've got it. So I've got this curve that I will use as a camera path. So the camera will go along it. And under this panel, I'm gonna select this curve with this button. So select the curve. Now I can actually hide it. And I just need to define an animation name, frames per second, or the total duration of it. Let's say that I want it to last 10 seconds. And then I've got the option to record this animation, either by choosing the Rhino display, which is what we are seeing now, or choosing the current renderer. Okay. Of course, choosing this option, it will generate a render for each frame. So it will take a lot of time. It's not maybe the moment to do this, but just by choosing Rhino display, we could record a video of this animation. If you just want to see a preview of it, just run the play command, and you will get an idea of how this animation will look like. Okay. Another possibility is to navigate through the project with the walk command, the walk mode. When we click on it, Lands puts us on top of the model, and just by moving the cursor from one direction or another, we will be navigating through the project as we were kind of interactively walking through it. Okay, because with escape button we exit this command. Actually, I'm seeing kind of cut. I think this happens because these axes are very, very long. So if you define here like a finite segments, we will get this problem of the image being cut a little bit. So I'm gonna play the wall command, and we will better see what's going on here. Okay, with the mouse wheel, there is the option to increase the speed of navigation. So I recommend, if you want to explore all the options with the wall command, I recommend you taking a look at the Lands help, where you will see which are the all the keyboard controllers for using this navigation mode. Okay.
There's a question. Can that animation be run through Enscape?
Yeah. Actually, there is a possible to connect with Enscape. Okay, so you can see all this model directly in Enscape. So if you have the Enscape for Rhino plugin installed, you just need to run it, and you will see all this project in Enscape live, running live.
Actually, Enscape has a great synchronization with Lands Design.
Yeah, actually, in the gallery there are some projects that are rendered with Enscape, so you can explore them in the website's gallery. I don't know if there is time for go
another
on.
question about render. How about Lumion? Well, we've got nice results with Lumion from our users. You can see them in our project gallery. Maybe. Well, apart from compatibility with the program, you must check your system requirement regarding that type of render. Here you see different results in our project gallery. These are projects that are done with Enscape, Lumion, or Twinmotion. In this example, it's done with Enscape. But there are other examples with Lumion or with Twinmotion and some other renders. Private garden in Shahryar. Yeah, this one as well. Yeah, this one. These are with Lumion. Yeah.
Good. All right. I don't know if there is time for some more demo for integration with Grasshopper, or maybe I don't know. It would be
Yeah, we have time.
Things to. Okay.
But feel free if you have any other question. Well,
Yeah,
any
sure.
Rhino inside Revit features provided? Yes. There's a question.
Actually, the Rhino inside Revit, let's say, interoperability is possible because of the Lands component in Grasshopper. So I'm going to show a few of that feature. So when you have Lands Design installed, and if you open Grasshopper, for those that don't know Grasshopper, well, it's an application that runs on top of Rhino that lets you generate algorithms, okay, with components that represent geometry, values, operations, so you can develop scripts in a visual way very easily without having programming knowledge skills, and it lets you automate workflows. So we've got all the Lands components available from here. So for example, we can create plans from one specific position. So we can reference here maybe a point, okay, that we've got in some specific location. Okay. But my point reference here with this component, so this can be the position of my plant. But imagine that you want to have an array of plants in a gridded radial distribution. So we've got here a component that makes this radial distribution, and we can have this position, okay, as the center of this radial, and just by changing, the size of this. I'm gonna change this to have maybe a bigger value. we can have a parametric distribution of this radial array, and this component generates cells and points. So I can use, instead of a single point, I can use all these points as the position of my plants. Okay, so you can have integrate land design into these parametric workflows, and this also helps to integrate land design with Rhino inside Revit. So Revit has, I mean, when you launch Rhino and Grasshopper from Revit, there is here an additional tab for Revit components, so you can deconstruct this plant. For example, we can deconstruct here the plants, so we can obtain the position, we can obtain the option to know the height. We can also explode the geometry, the land's geometry. So we can explode the geometry and send it to Revit as direct shapes. Okay, so you can integrate land design with Revit that way. Actually, I'm going to show another definition.
Yeah, before moving on, there's a question about geolocalizing the document, actually, because
Okay.
Lucas is telling that they got the information from Surveyor, and then they start modeling, they start designing the landscape, and so they need to, or they can indicate XYZ of the document according to what they import from Surveyor, of course, or of course there another option that he's also asking is that set XYZ of one point of your project into 0 and start in Rhino. Yeah.
Okay, let me finish with this example and then we get to that point. So this is just an example of just by selecting different plants. I mean, I can insert the plants here in a paint mode very quickly. I'm gonna select these plants. Let's say that they are that size, and I'm gonna paint them over here. Okay, so it's got stuck for a second. Okay. So what this definition does basically is I'm going to reference these plants, okay, and I deconstruct these plants so I can obtain their height and their dimensions. So I do right click to set multiple plants, and from the position of the plants and the height, I construct these kind of pots below that will take the plant size, okay, and they will join with others if they are close enough to one to another. So this is just a definition that does this design, and later on we can control the size of these pots and the thickness of them. So we have a parametric design with a few components. Okay, let's mention about this geolocation. When we're working on Rhino, by default, the 0 coordinates corresponds to specific geolocation in the world. So by default, it takes some value. I think by default it's 0, 0, but if you already define it in a document, of course, you will see that here. If you go to Rhino document properties, there is here location, where you can specify, we defined the location before with the sun from the sun panel. So here you can specify any location in the world, or you can just type, the latitude and longitude from these values. But if you want to have these values referenced in one specific point in the model, you can run the Earth anchor point command. Okay, this will ask you to define the Earth location, and then set the model point corresponding to that location. Okay.
For example, select one corner, please.
Yeah, I actually picked one random point over there. You define the north from this command. And yeah, and you will have the document geolocated on that specific point. You need to select also the east or west direction to complete the command. Then you have some identification that you can actually skip this. Okay.
Well, there's a question from Matt. Is it possible to calculate mass balance with lands design?
Mass balance.
Can you open your mic, Matt?
Yes. Hi. Now I'm wondering, often we have to calculate how much mass we either have to transport away or bring to the site. Is there a method to do that in lands design?
Well, isn't it something that we already have calculated? You see the fill volume and dig volume.
Exactly. Okay.
So this is something that is calculated automatically.
Yeah, I see. So, but if you have let's say you start working with an existing terrain, and then all these will be listed up here.
Well, when you import your existing terrain, or if you already have it created by control points, for example, or by point cloud, for example, once you open it in lands design and start doing any kind of operation, all operations will be quantified finally.
I see.
So yeah. So you will have all the information. Yeah.
There is a question about is it possible to plan also drainage comparing to the irrigation?
Yeah.
There is no such a feature. But we are keen to hear from any requests on that subject. If you want to send us an email or share.
Well, actually, yeah, there is no specific tool for that, but you can use the irrigation tools for indicating your drainage system instead of irrigation, or you can draw two different layers, two different irrigation, and call one of them as drainage. So yeah, there's a workaround. Yeah. Well, thank you very much, Francesc. Thank you, everyone, for attending this session. I don't know if there is any other question. Well, just feel free to contact us by email. And yes, there's a 90-day free trial that we are inviting you to install it and try it out by yourself. Thank you. Bye.
Thank you. Bye-bye.